Let's talk about molecular shapes: linear, trigonal planar, and tetrahedral. We use valence shell electron pair repulsion theory. Now, we know that electron pairs will move to get as far away from each other as possible. They move around the nucleus at a pivot until their energy is minimized. With two electron pairs, they'll be 180 degrees apart. If they get any closer together, they will have higher energy. Suppose there are three electron pairs. Now we know if they have to stay the same distance around the red circle, they're going to look like this. But they also have to get as far away from each other as possible to have lowest energy. So the bond angles must be 120 degrees, 1/3 of a circle. But if we add a fourth pair of electrons, as when carbon bonds to four other atoms, we might form a square, but that's not the lowest possible energy. There's a three-dimensional character to all molecules. We can move in and out, not just up and down. So if we arrange them around a central point, equidistant and from each other, they will arrange themselves at the corner of a tetrahedron with the smallest atom in the back. So with two electron pairs, the electrons line up in a straight line on either side of the nucleus, linear. If there are three electron pairs, they will form an equilateral triangle around the nucleus with a bond angle of 120 degrees. That's trigonal planar. And if there are four electron pairs around the nucleus, they'll form up in a tetrahedral geometry. Our next step in forming our molecular shapes is to add the atoms which the central atom is bonded to. You'll use Lewis structures as a start. Now let's view a show on Lewis structures and Vesiper.